Okay, in this video I'm going to look at a few more examples of compositions of functions. So in the previous example I gave you a formula for a function and asked you to find a composition, but we could also do it given just a table of data. So let's try that. So given a table of data, I want to try and find f of g of 2. So my input is 2, and I'm supposed to first find g of x, or g of 2. So looking at the function g, if my input is 2, g of 2 would be 4. So this g of 2 on the inside is going to be a 4. And then after that I'm supposed to find f of 4. So plug in x equals 4 into the function f, and we get f of 4 is equal to 0. And so in this case, f of g of 2 is equal to 0. It also wants me to find g of f of 2. So this time I first find f of 2. So plugging in x equals 2 into the function f. So f of 2 would be 1. So the corresponding y for x equals 1 would be 2. The corresponding y, when x is 2, is y equals 1. And I have to be careful because which y are we talking about? Y equals f or y equals g? And this one is saying f, so apparently the corresponding y is 1. And now, once I figured out that f of 2 is equal to 1, g of 1 says plug x equals 1 into the function g, and we get the number 3. So very different middle steps, very different answers. These two are not related to each other, other than the fact that they're built on the same two starting functions. But I'm not expecting to get the same answer. Okay, let me look at another example about what exactly does a composition mean, how exactly might we use it. And I'm going to look specifically at, I'll look at pizza. So we could think about area depends on the radius. If we're talking about a slice of pizza, sure, the area of a slice of pizza depends on the radius. Or sorry, the area of an entire pizza depends on its radius, and we actually know a formula. Pi r squared would be the area of a circle. So we actually have a particular function in mind, but even still, we have area as a function of radius. But also we have, if I'm planning on going to a shop and buying a pizza or ordering a pizza, the cost theoretically depends on the size. The more materials they put into the pizza, the more it's going to cost me, the more pizza I'm going to get. So the cost somehow should depend on area. So I guess cost will be a different function that depends on area. I don't know what the formula is for this one, because I just made this up. So maybe Papa John's could tell us what their formula is for how to determine the cost based on an area. But even just still looking at the variables that we have, you input an r into this function and it spits out an area. This other function, you input an area and it spits out a cost. So the only way that it makes sense to combine these two functions is to turn radius into an area into a cost, which means we're first going to apply f to go from r to f of r, which is an a, and then after that apply the function g. G of a would be g of f of r. And so the only composition that makes sense is g of f of r, which is also g of f of r, which hopefully makes a little bit of sense because the inside of the parentheses would be our area, and the answer, g of area, should spit out cost. So the point I'm trying to make is that sometimes the output of one function is the same as the input of the other function if we have particular units in mind. For instance, area, radius, cost. The output of one function is the same as the input of the other function, and then it makes sense that I would want to take composition in this order and not in the other order. Because I want my output of the one function, which is area, to be the input of the other function. I don't want to switch the order of these two. I don't know what that would even look like.